Okay, so we just learned about formula writing, and we're going to start talking about naming next. But before we do that, we want to talk about Lewis dot structures of molecules. And we drew them for atoms before, so now we're going to combine what we learned about that with the formulas we just learned. So we're going to review a few things here. So how can we find the number of valence electrons an atom has? And remember what a valence electron is? That is the number of electrons in that outer energy level, or that last ring. And we can find that by looking up the group number on the periodic table, and it's that last number of the group number. Okay, so now we're going to review how many valence electrons an atom wants to have. And if you recall, it wants to have a full outer energy level, so it wants to have 8. So then the question becomes, well, how does it get 8? If it doesn't have 8, how does it get it? Well, it's going to do a few different things. It's going to either lose some electrons. So if an atom has 1, 2, or 3 electrons, they're going to lose those. Or it's going to gain them. So if it has 5, 6, or 7, then it's going to be easy to gain them. Or sometimes they're just going to share electrons. When atoms give and take electrons, that's what we call an ionic bond. Because remember, when you lose electrons or when you gain electrons, you have a charge. And when atoms have a charge, they're called ions. So that's where they get that from, ionic bond. When atoms share electrons, this is called a covalent bond. Okay, so here is when we're going to actually learn how to draw these structures, and it can be kind of difficult, so let's just take it one step at a time. So a bond is going to be represented by a line, and a bond is going to be 2 electrons. Electrons that are not bonding, they're going to be represented by dots, so that's nothing new. And they're going to be on pairs on the other sides of the symbol. So that's kind of like what we've seen before. Now, the first thing you need to know whenever you're drawing a molecule is what shape is it going to be. So have this written down, draw this out, and then you can refer back to it. So if you just have 2 atoms, there's really only one way for it to look. So you're going to have the 2 atoms side by side. So in this case, we're going to do a chlorine molecule. 2 chlorines that are bonded together, and then the bond would be in between them like that. If you have 3 atoms, then it'll be a similar kind of thing. You would have one atom that's by itself. So this is water, right? H2O. You have the one by itself in the middle, and then you have a bond on either side. So still a straight line. If you have 4 atoms that are bonding together, okay, so it's going to kind of look like your water situation, but then you're going to have one like on the bottom. So NCl3 is kind of what you're looking at here. And so you have the one atom that's by itself in the middle, and then on 3 different sides you're going to have a Cl, or the other atom. Okay. And then kind of a similar situation here, if you can imagine, if you have 5 atoms, 4 will be the same, and then 1 will be by itself. The one that's by itself will be in the middle, and then the 4 that are the same will be on each side. So that's the general shape. Notice I didn't put any dots on any of them because I didn't want to overcomplicate things for you. Okay, so what happens if they are going to give away, take, or share more than 1 electron? When atoms share 2 pairs of electrons, that's going to be called a double bond. So can you imagine what it would be called if they're going to share 3 pairs of electrons? Yeah, it's just a triple bond. And that's as big as it can go. Okay. So let's practice this. So the first thing we need to do is figure out if this guy is ionic or covalent. Okay, silicon, one silicon with 4 chlorines. Okay, and the name of this would be silicon tetrachloride, and we haven't learned that yet, but we got to figure out where they're at on the periodic table. Okay, so silicon is right here, and chlorine is right here. And so we have to figure out, are they non-metals or metals? And here's my dividing line, if you remember, right here. So they're both non-metals. So this one is covalent. And then what you want to do is put that one that's by itself in the middle. And then the 4 are just going to go on each side of it. And you're going to draw your bonds in there. And remember, the bond is going to represent 2 dots. 1 dot, okay, from the chlorine here, and 1 dot from your silicon here. So after you get the general shape of it lined up, that's the hard part. And then you just want to see how many dots everything's supposed to have. So if we come over here and we look, silicon is in group 4, it should have 4 dots. Well, silicon has 1 dot here, 1 dot here, 1 dot here, and 1 dot here. So silicon's dots are all on the line. Now chlorine is in group 17, so that's 7 valence electrons. So all the chlorines have 1 dot on the line, and they need 6 more dots. So let's just go ahead and put them on there. So 1, 2, 3, 4, 5, 6, and the 7th one is on that line. Okay, so it's a lot of dots. So our silicon tetrachloride is finished. We know it's covalent because they're both nonmetals. Okay, let's try another example. So again, the first thing you want to do is figure out whether it's ionic or covalent. The last one was covalent, so it was sharing electrons, and so let's look at this one. So calcium is right here on the left, and oxygen's right here on the right. So that means this is going to be ionic. Okay, so the difference between when you're drawing one that is covalent and when you're drawing one that's ionic is the way that you're going to draw the lines. So there's 2 atoms here, so we got to figure out the shape. So if there's 2 atoms, it's just going to be a line, right? There's really no other possible way it could be drawn. So we're going to draw a Ca, and we're going to draw your O, and then a line in between. And what we're going to do on this one is we're going to show which direction those electrons are going to be going. Okay, and I have it pointing towards the O. Let's figure out how I determine that. So let's look up calcium. Calcium is right here in group 2. It has 2 dots. So remember, one of those dots is right here on the line, and there's my 2nd dot. Now my oxygen is right here in group 16. So we need 6 dots. Remember, one's right here on the line. So 1, 2, 3, 4, 5, and 6. Okay, so there is our dots, and the reason I knew calcium was going to give away its electrons to oxygen was because calcium had 2 and oxygen had 6. So calcium's going to give away and oxygen's going to take. Now, do you see something else wrong with this picture? Do you see how calcium has 1 left over here and oxygen has 1 lonely guy here? So this is that situation we were talking about called a double bond, or where calcium is going to give away 2 pairs, 2 electrons basically to oxygen. So the way we're going to indicate that is we have another arrow showing that that electron is going over to oxygen. So this isn't really a double bond necessarily. A double bond's really for covalent, but we have 2 electrons from calcium going over to oxygen. Okay, so we're not going to do any practice problems here. Just wanted to give you those 2 examples, and then tomorrow in class we are going to spend the whole hour practicing this.